about Latin square design. So this is just a basic example of a Latin square design. This is a 3x3 design, and each row and column has no repeated variables of x, n, or s. You'll notice this is just like Sudoku, and that's because Sudoku is essentially a Latin square design. But with this example, I just wanted to show you what a Latin square design looks like. To discuss what a Latin square design actually is, I need to first talk about randomized layouts, which in an experiment, the layout is just the physical arrangement of the experimental units. In order to tell what a Latin square design is, I must explain the difference between a complete and incomplete layout. So a complete layout is when every possible combination in an experiment has at least one observation per factor of levels. An example of this is if there's yellow, red, blue, and green samples with levels of 1, 2, 3, and 4. The samples and levels are respective, and there are the same number of factors as levels. Complete layouts are used when multiple factors of an outcome need to be studied, or the factors need to be analyzed simultaneously. However, it's not commonly used because of the high cost, and in some cases a complete layout is actually impossible due to the experiment's natural state because of the impractical uses of time, money, and resources. Now, for incomplete layouts, it is an experiment where every possible factor does not have a respective observation per each combination, so essentially the opposite of a complete layout. The number of factors does not have to equal the number of observations, and this is actually what a Latin square design is. A Latin square design is a multi-factor design in which observations or treatments are applied to different factors in a distinguished combination. A Latin square consists of columns and rows and treatments represented by symbols that are randomly placed in an x by z square. Number of treatments or observations is always equal to the number of rows and columns, and each row can only have one treatment of the ones being analyzed, and same for the columns. Also, this should be chosen randomly. Latin square designs are used when variation is desired to be controlled, and you have at least two blocking factors, or you want to get rid of at least two extraneous values. This is just the calculation page for the ANOVA table for Latin square designs. Here we have a Latin square design when it's been applied to an engineering hypothesis. As you can see, each corner has different weather conditions, and within those corners are 3 different types of concrete treatments and 1 with no treatment. This exposes all of the different ways the concrete treatments could be affected by the weather, so you could examine and determine which treatment performs best under certain weather conditions.